So we'll now discuss higher order derivatives first. These are discussed in section 2.6 of the book. Now, our starting point is an interval I containing a point A, and it is the interval A minus delta, A plus delta. So we draw a picture, we have this A sitting in the middle of this interval of width delta, and say we have some function f. Now you know that this function f is differentiable on the interval I if the following holds: if the limit for h to 0 of the function value valued at point x plus h minus the function value at point x, so the difference in output divided by the difference in input, if this limit exists for all points x in the interval. And then if this limit exists, we will call it f prime x, and we call this function the derivative. Now, of course, we can continue this procedure, and we will look at the derivative of the derivative. So we call f twice differentiable on the interval I if both f and f prime are differentiable on this interval, and then we call the derivative of derivative, we denote it by f2 or f double prime, and this is the second order derivative. Now clearly we can continue this procedure, and then we say that f is n times differentiable on this interval if it is n minus 1 times differentiable and the nth minus 1th derivative exists. So fn minus 1 is differentiable on the same interval. Then we denote the nth derivative as the f with a superindex n, and this is the derivative of the nth minus 1th derivative. Of course, this is quite simple, but it's good to give some examples. So suppose that we have the function f of x is e to the power x, then we know that the first derivative is the same as the function itself, and so if we differentiate once more, we get the same derivative, and so on. So each derivative is equal to the function itself. Another example is when f of x is sine of x. We know that the derivative is cosine. If we differentiate again, we get the second derivative. This is equal to minus the sine, and so on. So the third derivative is the derivative of minus sine of x. It's minus cosine of x. And this is just a swapping procedure. Now, maybe more interesting is when f of x is 2 to the power x, for instance. We know that the derivative is the same function multiplied by the natural logarithm of 2. And so if we differentiate once more, we get an extra term ln 2. And so if we differentiate n times, then we get ln 2 to the power n multiplied by the original function. Now the last example is the one of a polynomial. So for instance 3x squared plus 2x plus 1. And we get that the derivative is equal to 6x plus 2. The second order derivative is equal to 6. And then the third order derivative, well, you get nothing, is 0. And this is of course typical for all polynomials. So if we differentiate 1 times more than the degree of the polynomial, we get 0. So if f is polynomial of degree k, then we get that the k plus 1th derivative and all the higher order derivatives are 0.